Hi guys, welcome to this page of the notes, and you had to know there's no way we were going to get through a lesson without talking about the Pythagorean Theorem, especially considering that this chapter is all about right triangles. And that's what Pythagorean Theorem does. Pythagorean Theorem will allow you to solve for an unknown side of a right triangle, as long as you know the other two sides. In this case though, we're going to look at a couple of special cases of the Pythagorean theorem. And these are what's known as Pythagorean triples. And here's the only reason that these guys are special. It's simply because when you use the Pythagorean theorem, everybody, A, B, and C, all three sides, come out to be positive integers. And this is a little weird. I mean, just think about it for a second. We have done the Pythagorean theorem many times in geometry this year, and rarely, very rarely, I mean, just think back to the problems that we've done, very rarely have we wound up not getting a radical when doing the Pythagorean theorem, right? You wind up with some number you can't take the square root of. At least it's not a perfect square, right? We wind up getting some non-perfect square. The deal with the Pythagorean triples is that will not happen. If it is a Pythagorean triple, A, B, and C will all be positive integers. You will not get a non-perfect square when doing these problems. So, here we go. Here's the way these are going to work. You're going to be doing the Pythagorean theorem, and you're going to be doing it a lot. So, A squared plus B squared is equal to C squared. And I give you this one right here. We're going to start with this guy, 3, 4, and 5. I want to know, is this a Pythagorean triple? Well, start plugging stuff in. 3 squared plus 4 squared. The order of these two numbers doesn't matter. 3 and 4 are interchangeable because they're both the length of the legs, and the legs are interchangeable. Doesn't matter which order. Please keep in mind though, the hypotenuse is the longest side. So the 5, which is the biggest number, must go in for C. You cannot move 5 somewhere else. You won't get the right answer. But as long as I put the hypotenuse in the right spot, the 3 and the 4, those guys don't matter. Well, 3 squared is 16. Oh, nope, it's not. It's 9. 4 squared is 16. And 5 squared is 25. What is 9 plus 16? You betcha, it's 25. And cuckoo, ka-choo, look at you, right? We get ourselves a Pythagorean triple. How do I know it's a Pythagorean triple? Well, first when I set this guy up in the Pythagorean theorem, right, I wind up getting a true statement. 25 does equal 25. And all three of these numbers are positive integers. There are no radicals in here, right? Pythagorean triple. Try this one. See what we get. A squared plus B squared is equal to C squared. Well, what's my hypotenuse? The biggest number. The longest side is my hypotenuse. So as long as I put the 17 in for C, the other two, they don't matter. It doesn't matter where they go. 8 squared plus 15 squared is equal to 17 squared. Don't fat finger something on your calculator. 8 squared is 64. 15 squared is 225. And 17 squared is 289. No, I don't expect you to know those. Please make sure you have a calculator with you. Quickly punch those in and do a little bit of arithmetic here. We wind up with 289 is equal to 289. And cuckoo, ka-choo, look at you. Pythagorean theorem checks out, so I know that these can be, it is possible for those to be the three sides of a right triangle. It's possible, and all three of them are positive integers. So it's a Pythagorean triple. Okay, here we go. More importantly, solving an actual problem. So here we go. I give you a right triangle, and I ask you to find the length of the unknown side, in this case the hypotenuse, and then tell me, is it a Pythagorean triple? I don't know. Let's find out. A squared plus B squared is equal to C squared. Since I did not give you the length of the hypotenuse, that means we're going to be solving for C. 24 and 18 doesn't matter where they go, they're interchangeable. So 18 squared plus 24 squared equal to C squared. 18 squared, I get 324. For a 24 squared, I get 576, which means a c squared is equal to 900. Take the square root. Take the square root of 900 and I get c is equal to 30. Question, Pythagorean triple. Yes, right? All three numbers are positive integers. I didn't get any square roots. I don't have any radicals. 30, 24, and 18. All of those are positive integers. And so yes, this is a Pythagorean triple. Awesome. Let's try another one. Here's my next one. Once again, it looks like I'm having you solve for the hypotenuse. So again, you can plug in the 16 and the 25 for either A or B. Doesn't matter. You're going to be solving for C. In fact, let me go ahead and set up the Pythagorean theorem this way. C squared is equal to A squared plus B squared. That way my C is already on the proper side. And I wind up with C squared is equal to, whatever, we'll do 60 first. 60 squared plus 25 squared. Again, don't fat finger something on your calculator. 60 squared is 3,600. 25 squared is 625. We get c squared is equal to 4,225. Again, you're just using your calculator to do a little bit of quick math here. And c, we're going to take the square root of 4,225. There's no way that's a perfect square. Turns out it is. Comes out to be 65. So now the question is this a Pythagorean triple? The answer is yes. Positive integer, positive integer, positive integer. I didn't get any radicals, no non-perfect squares, and so yes, this is also a Pythagorean triple. You're probably thinking to yourself, there's no way he gave us 3 Pythagorean triples in a row. One of these can't work. Well, let's find out. Here's the next one. The length of the hypotenuse is 8. The length of the leg is 4. We need to find the length of the other leg. A squared plus B squared is equal to C squared. So we'll do A squared plus a 4 squared is equal to 8 squared. This one's maybe a little bit easier. 4 squared is obviously 16. 8 squared is 64. We'll subtract the 16 to the other side. 64 minus 16, you wind up with a squared is equal to 48. I have to take the square root of 48. Is 48 a perfect square? No. No, it is not. You actually can simplify it. 48 is 16 times 3, which would come out to be 4 square roots of 3. But here's the point, right? I wind up with a square root of 3, which is a non-perfect square. I wind up with a radical, right? Remember, I just found the length of this guy right here. This guy is 4 square roots of 3. Pythagorean triple? No. Why not? That's not a positive integer. Right? It's an irrational number. It's a non-repeating decimal. You take the square root of 3 and you get some big, long, ugly number that never ends. So, not a Pythagorean triple because I don't wind up with all positive integers. Alright guys, thank you so much for joining me for this set of notes. I really had a great time taking a look at those 2 special right triangles, the 45, 45, 90, the 30, 60, 90 right triangle, and how the ratio of the sides is related in both of those special right triangles. I really had a good time. I'll see you.